that what is the probability, right? And what are the different terms which are related to this chapter or this topic, probability, right? So in your class 9, you have already studied about the concept of empirical probability, right? However, empirical probability is based on experiments. We can also call it sometimes experimental probability, right? For example, suppose we toss a coin 500 times and get a head, right? Suppose 240 times we are getting head, right? And we 260 times we are getting the tails, right? Okay, so we are tossing the head 500 times. So suppose we are tossing a coin 500 times. Okay, we know that there are two outcomes when we toss a coin, a head and a tail, right? And now head comes 240 times, whereas tail comes 260 times, right? Then what we say? We say that in a single throw of a coin, the probability of getting head is 240 upon 500, right? You can convert this into the simplest form, that is 12 upon 25, right? And again, suppose we toss a coin now this time we are tossing a coin 1000 times. We are tossing at the coin 1000 times and we are getting head, for example, 530 times and tail 470 times, right? Now, what we would say that in a single throw of a coin, the probability of getting head this time is 530 upon 1000, that is 53 upon 100, right? That means what? In various experiments, we would get different probabilities for the same event, right? So event is same. What is the event? Event is the head. Event is the head, but their probability are different for the different experiment, right? So this is experiment number 1, right? And this is experiment number 2, right? We are tossing the coins, right? In experiment 1, we are tossing the coin 500 times. In experiment 2, we are tossing a coin 1000 times. And in both the cases, the probability of getting head is different, right? Okay, so the theoretical probability overcomes the this above this problem, right? Okay, means the experimental probability and the theoretical probability, they are two different things, right? So theoretical probability overcome this problem, right? Because in every experiment you can find that you are getting different number of heads, different times heads and different time tail. So you cannot say by just considering a single experiment that this is the probability of head every time, right? So in this way we always find out the theoretical probability which overcome this problem, right? So now in this chapter we will learn about theoretical probability. Is that clear? So let's see what is the meaning of probability. So probability is a concept which numerically measures the degree of certainty of the occurrence of events, right? So what probability tells us? Probability tells us the degree of it measures the degree of certainty of the occurrence of any event, right? Is that clear? So before understanding probability in a more deeper way, we should know there are certain terms and concepts which we should know about it, right? So let's see one by one. What are these? What is experiment? What do you mean by experiment? Experiment is an operation which can produce some well-defined outcomes, right? And that is called an experiment. Okay. So, so what is an experiment? An experiment is an operation which can produce some well-defined outcomes. That is called experiment. Is that clear? Okay. But what is a random experiment? What is the meaning of a random experiment? Random experiment means in which all the possible outcomes are already known. We already know what can be the possible outcome, right? But the exact outcome cannot be predicted in advance, right? You know what can be the outcomes, what can be the possible outcomes of that random experiment, but exact outcome cannot be predicted in advance. That is a random experiment. Is that clear? Okay, so if we see like different examples of random experiment, then you can say like tossing a fair coin, right? Example of a random experiment is tossing a fair coin or a tossing a coin, right? We know that outcomes are either head or tail, right? The possible outcomes are already known, but we cannot predict what will be the outcome exactly. It may be head, it may be tail, right? Similarly, rolling of rolling of a die, right? Okay, it should be unbiased. Similarly, drawing a card from a pack of well shuffled cards, right? Picking up a ball from a bag of the balls of different colors. So these are all examples of random experiments where we know what can be the possible outcome, but we cannot predict the exact outcome in advance. Okay, so these all are random experiments. Is that clear? Now, what is an event? What is an event? What is an event? The collection of all or some of the possible outcomes is called an event, right? So write down the collection of all or some of the possible outcomes, some of the possible outcomes is called an event. Okay, for example, if you throw a coin, head is the event of H is the event of getting head, right? If you're throwing a coin, okay, then H is the event of getting head. Okay, suppose we throw two coins simultaneously, right? If we throw one coin, then H and T are the event of getting head or tail, right? Now suppose we throw two coins simultaneously, right? Two coins are throwing. So now event can be like getting at least one head, right? So what is an event? Event is getting at least one head. This is an event, right? Then what will be this event contains? This event contains HT, H, HH, and TH, right? So in all these three outcomes, you have at least one head. It can be more than one head, but at least one head, right? So this is an event, that getting at least one head is an event. And in this event, we are having these possible outcomes, right? So we are having three outcomes here, right? So what is an event? It is the collection of all or some of the possible outcomes in a random experiment. Is that clear? Now, what is the meaning of equally likely events? What is the meaning of equally likely events, right? What is the meaning of equally likely events? A given number of events are said to be equally likely if none of them is expected to occur in preference to the others, right? For example, if we roll an unbiased die, each number is equally likely to occur, right? If, however, a die is so formed that a particular phase occurs most often, then die is biased, right? That is not a true die, right? It is biased if any one number is coming again and again, right? So in that case, outcomes are not equally likely to happen. Is that clear? Okay, but if it is a fair die, then all the numbers are having same probability to occur, right? So that means each number is equally likely, right? So all the events are equally likely. Is that clear? So in this way, we can define equally likely events as that these are the events that have the same probability of occurrence, right? Okay. For example, like if you toss a coin, then getting head and getting tail both are having same probability of occurrence, right? So these events having same probability of occurrence are called as equally likely events. Is that clear? Okay. Now, what is the experimental or empirical probability? Experimental or empirical probability, right? This you have studied in your class 9, right? That empirical or experimental probability, PE, is equal to number of trials in which the event happened. Number of trials in which the event happened. This is divided by total number of trials. Total number of trials, right? So what is the empirical or experimental probability of event E? The probability of event E is that the number of trials in which this event E happened, divided by total number of trials, right? So this formula gave you the experimental probability of that event E, right? Where E is the event. Getting it? Now, what is the theoretical probability? Theoretical probability, also called classical probability. This is also called classical probability, right? So theoretical probability of an event E, okay? Theoretical probability of an event E. We are talking about event E. It is written as PE, okay? And this is equal to number of outcomes favorable to E, favorable to event E divided by number of all possible outcomes of the experiment. Number of all possible outcomes of the experiment. Is it clear? Right? So this is how we can find out the theoretical probability or the classical probability of event E. Okay, is it clear? When we are talking about the theoretical probability or the classical probability, we assume that here, what we are assuming? We are assuming that outcomes of the experiment are equally likely. Okay, they are equally likely. So when we are talking about the theoretical probability, we assume that the outcomes of the experiment are equally likely. So here, what we have assumed? We have assumed that outcomes of the experiment are equally likely. Okay, so in brief, what we say that whenever we say theoretical probability means we simply called it as probability. Okay, and this definition of probability was given by Perry Simon Laplace in 1795. Okay, so theory of probability had its origin in 16th century when an Italian physician and mathematician J. Cardan wrote his first book on the subject, the book on games of chance. This is the name of the book on games of chance. And the study of probability has attracted the attention of great mathematicians afterward. James Bernoulli, A.D. Mouveret, and Perry Simon Laplace are among those who made significant contribution to this field. Okay, Laplace theory analytic des probabilities 1812 is considered to be the greatest contribution by the single person to the theory of probability. And in recent years, probability had been used extensively in many areas like biology, economics, genetics, physics, sociology, in all these fields, right? So let's see how to find the probability for some of the events associated with the experiments where the equally likely assumptions holds. Okay. Now, before solving the questions, let's see what is the meaning of complementary event. Complementary event. We have seen what is an event. Now, let's see what is complementary event. Okay. So let's suppose E is an event. This is an event, right? Then not E, not E. If E is an event, then not E be an event which occurs only when E does not occur. Are you getting my point? Right? If E is the event, then not E will be an event that occur only when E does not occur. Is that clear? Right? So this can also be called as E dash, right? Suppose not E or E dash or E bar, right? Sometimes we call it like this also. This will be called as. So if E is the event, then not E or E dash or E bar will be called as complement of event E. Is that clear? Complementary event, right? So if E is the event, then not E will be its complement. Is that clear? Right? So the event not E is the complementary event. And if you add the probability of getting event E, means occurring in event E plus probability of the complementary event not E will always be equal to 1. Is that clear? Okay. Or in other words, you can say that PE, probability of event E, will be equal to 1 minus P not E. Getting that? Okay. So this is the probability of event E in terms of probability of not E, event not E, right? Or you can say then sum of the probability of event E plus probability of complementary event E will be equal to 1, right? It is exactly same. Like suppose you have the complementary angles. right? What do you mean by complementary angles? Whose sum is 90 degree, right? So if you have an angle 30 degree, right? 30 degree, what will be the complementary angle? 90 minus 30, that is 60 degree, because their sum has to be 1, right? So if an angle is 30 degree, its complement will be 60 degree, right? That is 90 minus 30. Similarly, when we say probability of getting an event E, right, is given, right? And we know that sum of all the probabilities can always be 1. Yes or no? Then what will be the probability of getting, of occurring, of not occurring E, right? What is the probability of not occurring E? That is the complementary event. Is that clear? That you will find if you subtract the probability of event E from 1, you will get probability of not occurring E, and vice versa. Is that clear? Everybody understood? Suppose, let's see an example to understand this. Let's see an example. Suppose we are tossing two coins together. Two coins together, right? Now there is an event. An event is getting at least one head, right? Getting at least one head, right? So what will be the possible outcomes for this event? Possible outcomes will be H, T, T, H, and HH. There are three possible outcomes. Getting that? Okay, right? So what is the probability of event E? This is equal to, how many outcomes are there favorable to event E? 1, 2, 3. That is 3. And what are the total number of outcomes? What are the total number of outcomes? Total number of outcomes, you can also write it first. Total number of outcomes. This is HT, TH, HH, and TT. These are the four possible outcomes when you toss two coins together. Getting that? Okay. So probability of getting an event E, that means at least one head. This will be, so this is 3 number of possible outcomes favorable to E, right? That is 3, and total number of outcome divided by total number of possible outcome, that is 4. This is 3 by 4, right? Now, if we want to find the probability of the complementary event, means when E does not occur, probability when E does not occur, right? Means probability of not E, that will be 1 minus probability of E. Getting that? 1 minus 3 by 4, which is 1 by 4. Is that clear? So in this way, you can find out what is the probability of the complementary event by subtracting the probability of event E from 1, because we know that their sum has to be 1 only. Is that clear? So this is the meaning.
Ma'am,
Okay, you start. Okay. So either you can find the complementary event, the probability of complementary event like this, or you can also find by finding out the possible outcomes of not E, right? So what will be the possible outcomes? Possible outcomes for complementary event E bar, right? What are the possible outcome? Only one, that is HH. There is only one outcome, right? Okay, and total number of outcome is 4. So what will be the probability of not E, or probability of E bar? This will be 1 by 4, right? So whether you find this way, right, or this way, you will get the same answer. Is that clear? So this is the meaning of complementary event. So let's quickly summarize this, right? For some event E, for an event E, right? The probability of getting E is always greater than equal to 0 or less than equal to 1. It will lie always in between 0 and 1. Probability of an event can never be less than 0, can never be greater than 1. It will lie in between 0 and 1. It may be equal to 0, it may be equal to 1 also, right? If suppose we are saying the probability of an event is 0, probability of occurring an event is 0, that means when it is possible, E is an impossible event, which can never be happen, right? And that's the reason its probability is 0. It is an impossible event, right? If we say that probability of an event to occur is 1, right? It's a maximum probability. That means when it is happen, when E is a sure event, it is a sure event. We are very much sure like this will happen. Is that clear? The probability of getting that event to occur will be 1. That is the maximum probability. Is that clear? Okay. So if suppose you are tossing a dice, right? You are or you are throwing a dice, right? So how many numbers are there? Numbers are like 1 to 6. Yes or no? Throwing a die, right? What are the possible outcomes? Either you will get 1 or 2 or 3 or 4 or 5 or 6. Now, if I say that what is the probability of getting 0? Can you tell me? What is the probability of getting 0 or getting 8? What is the probability of getting 8 if you're throwing a die? It will be certainly 0, right? Why? It is an impossible event because the die is having a numbers 1 to 6 only, right? So if you're throwing a die, you will never get 8, right? That means what? This is an impossible event. Is that clear? Now, if I say, what is the probability of getting number less than 7? What is the probability of getting the number less than 7? Right? So what are the possible outcomes? 1, 2, 3, 4, 5, 6, and 7. And all these outcomes are less than 7. Right? So what is the probability of getting less than 7 number? That is maximum 6. 6 out of 6. Maximum outcome, total possible outcomes are 6. And the number, you will get the number less than 6. Less than 7 is also 6. That means the probability is 1. Right? That means this is a sure event. Are you getting that? What is the meaning of sure event and impossible event? So if the probability of any event is 0, that means that event is impossible to happen. And if it is probability is 1, that means that event is surely possible, right? It will happen for sure. I hope you have understood this. Yes or no? And the fourth point to summarize here is P, not E, means the complementary even. This is equal to 1 minus PE. Okay. Is it clear? That is P of complementary event. You can also write it this way, is equal to 1 minus PE, or PE is equal to 1 minus PE bar. Is that clear? Okay. So this is how we can summarize all these things. Now let's start how to do the questions. Now look at this question. Question number 1. A die is thrown once. What is the probability that it shows 3, 5, an odd number, a prime number, and a number greater than 4? So there are 5 parts of this question in which you have to find the probability of each and every one part, right? So what is the random experiment here? The experiment is that a die is thrown, right? Now, very first, we will write down what are the possible outcomes when a die is thrown once. Okay. So all possible outcomes will be, it will be either 1 or 2 or 3 or 4, 5 or 6, because there are 6 numbers on the die, right? There are 6 faces, right? 1 number on each face. So the possible outcomes are 1, 2, 3, 4, 5, and 6, right? That means what is the total number of outcomes? Total number of possible outcomes, that is 6, right? You can count 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes. There can be 6 possible outcomes. Getting that? Now, let's see the first part, that a die is thrown and it show 3, means you're getting 3, right? So what is the event? Event is getting 3. Getting that? Okay. So let E1 be the event of getting 3, right? So getting a 3 is an event, right? And what are the number of favorable outcomes in which you will get 3? Can you tell me? In how many possible outcomes you will get 3 among these? How many times you will get 3? Only one time, right? So there is only one number, right, which is the favorable outcome, right? So write down the number of favorable outcomes of getting 3 is just 1, right? So what you can say, what is the theoretical probability of getting 3? Getting 3, this is equal to, means getting 3 means PE1, which we have assumed here, PE1, right? Getting 3 is an event here, is equal to 1 by 6, right? According to the formula. What is the formula? First write down that you have, right? Number of favorable outcomes, right? Divided by total number of outcomes, possible outcomes. This is the formula. right? So number of favorable outcome is just 1 and total number of possible outcome is 6. So what is PE1, or that is P getting 3 is 1 by 6. Is that clear? Now, similarly, let's see the second part. Probability of getting 5, right? So getting 5 is an event, and suppose this is event 2, E2, right? Okay, getting 5 is an event, right? So what are the number of possible favorable outcomes in which you are getting 5? Again, that is just 1. Yes or no? Okay. So 1 times you are getting 5 only, right? Here, this is only 1 times which can happen, right? So 1 divided by total number of outcomes. What is the total number of possible outcome? That is 6. So PE2 or P of getting 5 will also be 1 by 6. Third part. Now, what is the event here? An odd number, right? That you are throwing a die and you are getting an odd number. So very first you will write down what are the favorable outcomes, right? Okay. So suppose let E3, this is event 3, be the event of getting an odd number. Okay. Right. Now, what are the favorable outcomes? Favorable outcomes are favorable outcomes means how many times you are getting a number which is an odd number, right? So 1 is odd, 3 is odd, right? And 5 is odd, right? So what are the favorable outcomes in which you are having this event to happen? That is 1, 3, and 5, right? So what is the number of favorable outcomes now? Number of favorable outcomes, that is 3. There are 3 possible outcome into this event, right? So this is 3, right? Now we can find out probability of getting odd number. This will be equal to, according to the formula, number of favorable outcomes, number of favorable outcomes of the event divided by total number of possible outcomes, right? Okay. So number of favorable outcomes for the event is 3 and total number of outcomes are 6. So this is 3 by 6. You can write down this in the simplified form. So this is 1 by 2, right? So what is the probability of getting this event? That is odd number. You are getting odd number. This is an event and this is 1 by 2. Means half of the times it will happen that the number, when you are throwing a die, the number is an odd number. Is it clear? So because there are 3 numbers which are odd and total 6 outcomes are there. So what is the probability of getting an odd number? That is 1 by 2. Is that clear? So now in part 4, we have to find the probability of getting a prime number, right? So for again, let us assume that E4 be the event of getting prime number. That you are throwing a die and you are getting a prime number. This is an event. Is it clear? And suppose E4 is that event, right? Now we will find out what are the favorable outcomes for this event to happen, right? So the favorable outcomes. So what it will be? Number you will be getting 1, 2, 3, 4, 5, and 6. Now, what are the prime numbers here? 2, 3, and 5 are the prime numbers, right? So write down 2, 3, 5, right? So these are the favorable outcomes for this event to happen, that it is a prime number. Getting that? So we have written it here. Now, how many total number of favorable outcomes are these? Total number of favorable outcomes, that is 3. These are 3 numbers, right? Okay. And total number of possible outcomes, we already know this is 6, right? Total 6 numbers are there. So what is the probability of getting prime number? What is the probability of getting prime number? That means PE4, this event to happen, that is number of favorable outcomes for that event to happen divided by total number of possible outcomes, right? Total number of possible outcomes. Is that clear? So now put both the values. So number of favorable outcomes are 3, in which you will get a prime number, and total number of outcomes of that experiment, random experiment, is 6. So this is 3 by 6. Now again, you can write down this in the simplest form. This is 1 by 2. So what is the probability of getting a prime number? This is also 1 by 2, because half of the numbers among the total possible outcomes, the number of possible outcomes are prime numbers. 2, 3, and 5 are the prime numbers. So 3 times, right? There are 3 numbers which are prime numbers, and total outcomes are 6. So what is the probability that when you are throwing a die, you are getting a prime number? It will be half, 1 by 2. Is that clear? Now, in the fifth part, what do you have to find? In the fifth part, you have to find the probability of an event, and where the event is that you are getting a number greater than 4, right? Greater than 4. So let E5 be the event of getting a number greater than 4. Okay. So now, what are the favorable outcomes for this event? Favorable outcomes for this event to happen? Can you tell me? What are the numbers which are greater than 4 among all the numbers, among all the outcomes? That is 5 and 6 only, right? Only these 2 numbers are greater than 4. Rest all are less than 5, right? So favorable outcomes are 5 and 6. So what is the number of favorable outcomes? That is 2, right? And what are the total number of outcomes? Total number of possible outcomes? It is same. That is 6. Getting it? So we can find out the probability of occurring this event, that you are getting number greater than 4. Getting a number greater than 4. That means PE5. Right? This is equal to, again, number of favorable outcomes divided by number of total outcomes. Right? So number of favorable outcomes are 2 and number of possible outcomes are 6. So this will be equal to 2 by 6. Now you can again convert this into the lowest form. This is 1 by 3. So probability of getting a number which is less than 4 is 1 by 3. Is that clear? So in this way, we can find out the probabilities of different events, right? When an random experiment is occurring, right? So here, throwing a die is a random experiment where you already know what are the possible outcomes, but you cannot predict exactly what will be the outcome, right? So this is a random experiment where you already know the possible outcomes, the set of possible outcomes which can happen, but you cannot predict the exact value of the outcome. Is that clear? Right? And these are the events like getting a 3, getting a 5, getting 4, getting an odd number, getting a prime number, getting number less than 4, getting less than number 2, right? Okay, any event you can take, getting even numbers. Is that clear? And for these events, you can find out the probabilities. Is that clear? So in this way, we can do the questions, right? Based on how to find the probability of an event to occur, right? Now, you can go through this, whatever we have done today. In the next class, we will do some more questions related to probability, right? The events and the complementary events, elementary events, right? In the next class. Is that clear?
Yes,